Hello everyone. Today we are going to discuss about application of integrals. It has two types and area under the curve and area between two curves. Now we are discussing about area under the simple curve. So this is a curve represented by y is equal to f of x, which is SR, and it has covered the area PQRSR. Now our motive is to find the area of PQRSR. So we take the limits x is equal to a and x is equal to b, and we also take a vertical element area, that is dA, to find this PQRSP area. So the curve is y is equal to f of x, in which y is the dependent variable and x is the independent variable. To find PQRSP, we take a vertical element area as to find the whole area that's such that no small part gets wasted or we left the area. So now then we apply the formula, taking limits as a to b, that is area of dA. Here dA is the vertical element, which is a rectangle. The breadth is dx and the length is y. So it is y dx, applying the limits from initial point to final point, that is a to b, which is nothing but y is the f of x, that is equal to y is equal to f of x, which is the curve, f of x into dx, the differential element. So on integrating, we get the area of the required area, that is PQRSP. Similarly, we can find in the horizontal manner. On taking a horizontal, we take this as the horizontal element area, which is nothing but which is the same as dA, and here the breadth is dy and the length is x. So we write the equation as a equal to integral of x dy.
Good.
So here x is g of y. So integral of g of y dy. Now moving on to area under the axis. Below the axis the values are in negative sign. So we take modulus in the formula. Here the area and below the axis is in a curve which covers some part of the x-axis. So we take a difference. We take the vertical element area, which is nothing but same as dA. So a is equal to f of x dx. F of x dx is which represents the whole area, and the curve is y is equal to f of x. So it is the f of x dx, applying the initial limit a and final limit b. So integral of a to b, apply the modulus, as below the axis the values are negative. So area equal to modulus of a to b f of x dx. Next, moving on to area. Here the area is in the below the axis and above the axis. Below the axis, as I said before, the area come in negative value. So we apply only modulus to a1 and write the area of a2 as same as it is. So for a1 we apply integral of a to b f of x dx, and also for integral, then for a2 we don't apply a modulus as the values are positive. Next, moving on to circle. We can also find the area of circle by using integration. For that, we divide the circle into 4 parts and consider a single quadrant. In the single quadrant, we take a vertical differential element as seen. The equation of the circle is x square plus y square equal to a square. When finding this area, the formula is integral of 0 to a y dx. Because the point is a comma 0, we consider this point. So multiplying into 4, we get the whole area of the circle. So the formula becomes a equal to 4 into integral of 0 to a y dx. We need to find what is y here. So to find that, we take the equation of the circle. That is nothing but x square plus y square equal to a square. X square go to the RHS side, and it becomes y is equal to plus or minus root of a square minus x square. We take only positive values here, as the area cannot be negative. On finding y is equal to root of a square minus x square, we substitute in the formula, that is equal to integral of a to 0 y dx. And here we apply the integration formula of root of a square minus x square dx. that is nothing but x by 2 into root of a square minus x square plus a square by 2 sine inverse of x square bracket within the limits 0 to a and the constant is outside. Now we apply apply each value inside. On applying a, it becomes a by 2 into root of a square minus a square. So a square minus a square equal to 0. So this term gets cancelled. Now moving on to this term, it becomes a square by 2 and sine inverse of a by a. Sine inverse of a by a is sine inverse of a by a, which is nothing but sine inverse of 1, which is sine inverse of sine of pi by 2. So the value is pi by 2, where sine inverse of x by a and sine inverse of a by a, the value is pi by 2. So we apply 4 into a square by 2 into pi by 2 when substituting the value a. When moving on to 0, the whole term becomes 0. Yes, on applying 0 here, on applying 0, this term becomes 0, and also here a square by 2, this term becomes 0. So the whole term becomes 0. So 4 into a square by 2 into pi by 2. 4 gets cancelled and we get the final answer as pi a square. So the area, since we know that the area of the circle equal to pi r square, and we take the limit as a. So we get pi a square. So we can find the area of the circle using integration too. And similarly we follow the same method but taking horizontal differential element area. Horizontal element area. That is the small change here. Here also we apply the same thing, the same as we did, but here the differential element area is a equal to integral of 0 to a, as I said before, x dy. That is the small change here. Now moving on to ellipse, we can also find the area of ellipse using the integration. Here the area of ellipse is x square by a square plus y square by b square equal to 1. So now we consider the ellipse as same as circle. We divide it into 4 parts, take the element area, and the breadth is dx and the length is y. Same procedures have been followed. But here are 2 points, 0 comma b and 0 comma a comma 0. When you take a comma 0, the limit is 0 to a. When you take 0 comma b, the limit is 0 to b. It depends on the limits. So as same, we find the differential limit here, that is nothing but a is equal to integral of, I take a comma 0, so I apply the limit 0 comma a y dx. Now we need to find y. As I found it x square plus y square is equal to a square in the case of circle. But in moving on to ellipse, the equation is somewhat complicated. We need to simplify it and we need to find the value of the variable of y or the value of y. So y square by b square equal to, when this goes in right hand side, it becomes 1 minus x square by a square. Taking LCM, it becomes a square minus x square by a square. So this is nothing but y square by b square equal to y by b the whole square. Taking root on both sides, it becomes y by b equal to root of a square minus a square minus x square divided by a. So y by b equal to root of a square minus x square divided by a, and b goes to the right hand side, it becomes multiplication. So this is y is equal to b by a into root of a square minus x square. So we got the value of y, and as same we are going to substitute in the differential element area. That is nothing but a is equal to 4 into integral of 0 to a y dx. Multiplying on the 4, we get the whole area of the ellipse. So 4 into 0 to a b by a into root of a square minus x square, and b by a is a constant, it goes out of the integral. So 4 b by a into, applying the same formula, root of a square minus x square, integral formula is nothing but x by 2 into root of a square minus x square plus a square into sine inverse of x by a. On applying the same steps followed in the case of circle, we get the value as 2ab into pi by 2, that is nothing but a is equal to pi ab. So the area of the ellipse is pi ab. That is the value of a here in this point and value of b here in this point. And the same alternative method is we apply the horizontal element area and we apply the same steps, we get the same answer. No difference in the answers when we apply the vertical element area and the horizontal element area. We get the answer as equal as such.
Very good. Any questions?
Okay, please.
question? Okay. Thank you. Very good. Well
Thank
done.
you, sir.
Good.